our next speaker, Professor Stuart Phinn, is taking this data to a level that's absolutely fascinating in a place that's very dear to us all. We cherish it, and it's under great threat. So probably one of the most important places on Earth where this kind of science can have an impact. Stuart Phinn's the Director of the Centre for Spatial Environmental Research here at the University of Queensland, and he's going to talk to us about the Great Barrier Reef and the research he does there and how he's using spatial information to do that research. So please welcome Professor Stuart Phinn.
Okay, good afternoon, everyone. Before I start, I'd just like to acknowledge the traditional owners of the land and also the co-authors on my paper. So the presentation this afternoon, this was the question that Tim Forsman and the committee gave to me, what is meant by the Geospatial Revolution. So the question which I'm going to look at today in relation to that first one is, how's the expansion of Earth observation data, digital data and spatial tools changing our view of the world and our capacity for action in the world? So I'm going to talk about it from two perspectives. The first one's the Earth observation perspective. So that started a long time ago, or relatively long time ago, late 1950s, 60s. This is one of the first pictures of looking back at the Earth from almost out into space. Now we've progressed to views from the astronauts looking back, to collections of views from various satellite imaging systems, a lot of which we've seen today, from looking at the surface of the Earth, the oceans and what's in the atmosphere. And I'll talk about that today. I'll also talk about, is that something I just did in Photoshop or is it actually real? Okay, the other part of the perspective is, my perspective and my biases here. So I spend a lot of time in the field working with people, measuring what's out there. I collect satellite images and use them to produce maps which are used by governments, NGOs, private industry and research. And it's used for a whole range of things. But it's basically about understanding the Earth and how it's changing over time. So I do spend a lot of time out in the water looking at corals, seagrasses, but also in terrestrial environments, measuring how light interacts with these features. Because if we understand those interactions, what we can actually do is collect satellite images, apply some pretty simple concepts of physics to turn those images into maps, which tell us, in this case, how much suspended sediment's in Moreton Bay. We then put that in a format which is shared now a lot more easily across the web. And we produce web-based reports which people use, government reports and scientific papers as well. We spend a lot of time working with people to understand what it is they need and how they use this information and data. Maps are really powerful. They show a lot and they show a lot that's changing over time. Maps are like statistics. You can lie with statistics really well. You can tell whatever story you want. You can lie with maps really well too. If you take one message out of my talk today, whenever you look at a pretty picture, like the hundreds we've seen already, it's like, where did it come from? How is that produced? How accurate is it? Now, a lot of people take these things at face value, and it's really important to have a think about that because they're not often accurate. They're pretty good, but we need to think about that. So I'll come back to that later today. Okay, so what I want to show you is three things today to answer that question. The first one is to show how geospatial data and tools enable us to have vision, particularly to understand our environment and how it's changing. How they enable us to do science, particularly to measure what's in the environment and how it's changing over time, and particularly how our environment works and how society uses that, and also how we combine traditional knowledge with this new type of technology. I also want to talk about society lastly. That's been a common theme in a lot of talks today, is about empowering society, giving people access to information. Particularly about, in the case I'm going to talk about, is putting science into action. And I do see this as the main challenge that we face in the area that we all work in here, and we're getting better equipped to do this equitably, and we'll show some examples of that. So just while I'm talking, a question for you all to think about, your work in this area or related areas, how do you share it with other people and help them learn? And I'll come back to that at the end of today. So looking at the first point, vision. So how does geospatial data and tools enable us to have vision or understand what's there and how it's changing? Hopefully this animation's going to work. Okay, this isn't a basically put together with Photoshop. This is a collection of images collected from the CWIF satellite from 1997 through until 2010. Monthly images on the continents showing the amount of vegetation, and over the oceans it shows you the amount of chlorophyll concentration, which is the pigment that's in phytoplankton. And so what you can see is the Earth gradually changing over time, sort of breathing in and breathing out. So geospatial data is incredibly powerful for telling us that story and showing us how things are changing. Hop out of that. So just some examples, particularly in relation to Australia. We have highly dynamic ecosystems, whether it's desert ecosystems, the north of Australia, which is quite subject to burning every year, our wet tropics around Darwin and the areas to the east of that. Over 70% of Australia's woodland savanna, which has a dynamic over and understory. We have snow cover. Australia's snow cover is gradually changing and decreasing over time. We also have very tall forests. We've got a quite complex set of ecosystems there which people have to manage and work within and live. Geospatial data, like this is a map of vegetation cover. Bright green is the amount of vegetation. The bluish colour is the amount of brown vegetation, so browned off grass, and red is bare ground. Now we can produce this sort of imagery or maps every 2 weeks and look at changes in each of those environments I just showed you. So it's just a simple animation there. So we're able to build tools like that to see how the environment's now changing quite rapidly and easily over time. We're progressing a lot more in this area as well, which is not just what vegetation's there, but how much is there. So, you know, how much grass is there, how tall the trees are. Now we use satellite images to do that, like the Landsat image data. And you heard Lawrence Friedel talk this morning about what some of the long-term satellite programs. This is one of the satellite data sources we use. We can combine that with field information to produce maps of how much vegetation's on the ground. We can go to each point on the ground there and look at how it's changing roughly every 16 days. And we can look at how the tree canopy is changing, how the grass is changing. And that's important for a range of natural resource management activities. We're now at a point with other technologies where we can measure vegetation height and biomass, produce models like that, to produce a map like that showing you the height of vegetation everywhere. And we can look at that locally as well. That's in southeast Queensland. If we go down to an urban area, this is Brisbane at the moment, we're sitting down over here. Local councils around Australia are particularly interested in how much vegetation's there and how it's changing over time, and particularly if they spend tens of millions of dollars replanting trees, where's it actually going and is it having an effect on climate? So mapping and monitoring that over time is something we can look at that scale as well. We can also look at how much vegetation grows each day. That sort of ominous looking instrument there is part of a flux tower. These are international standard systems which are used to measure the amount of carbon dioxide in the atmosphere. The instrument on the right is a sonic anemometer. It measures wind direction and strength. This is a gas path analyzer here. There's a beam of light going in that path and it measures carbon dioxide concentration. You can actually match that up to the vegetation here and work out how much carbon dioxide the vegetation's breathing in and breathing out, and do things like this with that information and some simple models. So that's a map showing how much vegetation grows roughly each day in Australia that Vanessa Harvard and colleagues from CSIRO have produced. All the graphs around there are showing the individual point measurements from those flux stations. Okay, we can also look at crops now as well. So we're now down at the scale of looking at individual plants. So peanuts, how much peanuts are actually growing and the yield from them. Sugarcane, still a major commodity within Queensland, how much sugarcane is being produced each year. Bananas, particularly topical in Queensland at the moment. Thinking about John Richards' talk, we're now at the point here of combining human vision approaches with very high resolution imagery where we can identify individual banana trees, and this has been done for biosecurity purposes, map where they are, and also look at their condition from airborne imagery. Macadamia nuts as well, mapping where they are and estimating their yields. Also looking at changes in vegetation in relation to infrastructure. This is a project that was initiated as part of a government agency in Queensland where they are looking at the condition of vegetation along power line corridors. They developed a new approach which collects airborne laser data, which is three-dimensional point measurements. Here we've got a road with a power line and some vegetation around it. We can classify the data points there into what it is, whether it's vegetation, road or power line. Put that information, in this case, into Google Earth and visualise where the power line is. Have a look at where the vegetation intrudes on the power line area, and basically the area in red's the area that needs to be trimmed. So this was something that was developed within Ergon and has now become commercialised and used operationally. Just moving into the water, so that's southeast Queensland. We're over here in Brisbane at the moment, just in here. That area on the east there is the seagrass beds. We're able to work with a number of agencies using satellite imagery and field survey to map what's there. If we look at that area and look at Landsat imagery, we can see how it's changing over time. So hopefully looking at all those images I've just shown you, you can see, geospatial data does let you see what's there at a range of scales that people are using to make a range of different decisions from. Oops. Okay, the Great Barrier Reef. So off the Queensland coast, source of $5+ billion of income each year in Australia. So where is it and how much coral is there? We've got a pretty good idea where it is. So just like we know about topography on the land, we know about bathymetry in the water, and that's pretty well established. If we zoom in on one area, this is Heron Reef, which is just off Gladstone. This is the reef itself. The reef's in about 20 metres depth of water, and then there's a shallow reef which is 4 or 5 metres, and Heron Island's up in here. Now what we don't know is where all the coral is, how much coral's there, and how it's changing over time. We know less about the Great Barrier Reef than we know about the state of Queensland. We don't map it regularly, we monitor it at a range of sites, something we need to do something about. Okay, the second point I wanted to look at is science. How do we actually measure what's there? There's a graph of an environmental property over time. Now, this could actually be looking at someone's health over time and their heartbeat over time. In this case, we're actually looking at a series of properties and the amount of bare ground or the amount of vegetation on that property. I'll come back to that in a minute. And it's showing you the health of that property over time. The reason we're able to look at changes over time and measure how much change is actually occurring is through programs like NASA's and the USGS's Landsat program. And this is a graph showing from the late 1960s through to 2015, the Landsat series of satellites. We're currently at Landsat 8 as it is now. Australia benefits from billions of dollars of foreign taxpayer invested money in these sorts of systems, and also private systems for monitoring and managing our environment. So Landsat's been a critical program in helping us do the science over time. Just as an example of that, if we go to Central Australia in Western Queensland, this is out near Ethabuka. That's what it looks like on the ground. There's some people doing some measurements. We can actually look at how much vegetation's there over various periods of time, like that, from the imagery. And we can start to relate that to the animals and other features that depend on the environment. In this case, one of the sort of spinifex hopping mice. And we can then plot over time how much vegetation's there, how much bare ground's there, and how it's changing, and look at that in relation to, in this case, the small mammal numbers, and people are working out models to predict animal populations from the vegetation cover there. We can also look at people's properties, and particularly people who are implementing controls to try and increase the productivity in terms of their pastures, retaining vegetation cover. So this is a property which is just to the southwest of Townsville in North Queensland, where they've been trialling a number of different pasture management practices. What you can do is look at the satellite imagery, in this case in red, the time traces of a paddock which has had heavy grazing on it. And if you follow the red line on the bottom graph, you can see over time that the amount of bare ground increases. Whereas the paddock that's had the lesser amount of grazing on it, there's less bare ground, more green grass cover. So if you're going to invest hundreds or millions of dollars in changing land use practices, this sort of imagery can be used to do it. The Queensland government's actually been world leaders in this area over the last 15 or 20 years in building long-term field and image-based monitoring programs for looking at the amount of vegetation cover over Queensland and using that to help with vegetation mapping and monitoring. And again, that's thanks to programs like Landsat. European Space Agency is thinking a lot further forward at the moment. They look at all of the environments together. They actually have a series of satellites set up specifically to monitor environment or ecosystem condition over time. The second satellite in that series was launched successfully last Tuesday, and that's something that we're going to use in Australia in addition with the Landsat data. And that doesn't work. Okay, thanks. Okay, in terms of other data that we've got access to, geostationary satellite data. This is where the satellite's in the same position over the surface of the Earth. As the Earth moves around, the satellite keeps looking at it, so you get a view of a full disk. Japan's been very generous to Australia since the 1970s and let us use its geostationary satellites. It launched a new one at the beginning of the year, which is now collecting imagery roughly every 10 minutes over this whole disk, and it zoomed in views every 2 minutes, and that's close to near real-time imagery over an area. Okay, so last point there, or the third answer, is in relation to society. So geospatial data enables us to put science into action in society, whether that's dealing with cyclones, looking at where they're actually going and building plans for responding to them, whether it's looking at thermal temperatures within urban areas, helping to plan them more effectively and develop more green roofs and green building infrastructure. So geospatial data enables us to do that. The big shift now is that we're moving to more tools that enable more people to access these data sets. Google's been quite helpful in that space by putting a lot of global satellite image databases like Landsat online, so you can go in, access the data, use it, and pull it back to your own site. Amazon Web Services also put all of the Landsat archive up online for use in their areas as well. So now you don't need your supercomputer to do it, you can use someone else's to do it. This is just examples from Earth Engine where we've put code in there to process imagery over Australia and Queensland and deliver up-to-date information for landholders to access either on their desktop or on their mobile phones to look at changes in the amount of vegetation. And that's what the front end to the Google Earth Engine looks like. People can build their own code, like this one for looking at reef health and condition, and you can work with community and other groups to collect field data to validate that information. An example of that most recently is groups across Australia got together to put together field surveys of seagrass data sets with satellite imagery to map where all the seagrass is and how it's changing over time. That wouldn't have been possible 5 years ago. Community groups are now collecting field data that's geospatially referenced, putting it up on the web for people to use, whether it's looking at the condition of the reef, whether it's mapping seagrass, whether it's looking at mangroves, whether it's mapping coral reef conditions in different areas around the world. All these groups collect imagery which they put up online for us to use. Okay, so back to the question, how do you share what you know with others? Hopefully I've showed you that geospatial technology and tools enable us to do these three things there. They let us collect, analyse and share data, and they also let us to do that, enable us to do that more collectively now to understand what's there, how it's changing over time. They also help us recognise there are problems and work out how to solve them collectively over time. Looking at the conference as a whole, I think what I've covered today addresses the pivotal principles which are outlined in some of the documentation you have, which is the sort of imagery I've shown you and the capabilities I've showed you enable open and transparent access to data and information, more so than what we had 2 to 3 years ago. They enable spatial information to be used to look at what's there and how it's changing and build sustainable development activities. Most importantly, and I think you heard Peter Beattie stress this a lot at lunchtime, it lets you visualise science and how the environment's changing and lets people engage with it to get the community involved and to help them make decisions. And this graph is particularly important. It's out of a book I helped on a number of years ago. It's basically showing if you want to shift how people manage the environment or use the environment, you've got to have knowledge. You've got to get knowledge out there. Now, geospatial data is really contributing to providing this informed and empowered public, more so, I think, than any sort of enabling technology than we've had other than access to the internet and things lately. I wanted to finish with this slide. This is the Hokulea. This is a Hawaiian sailing canoe that's currently travelling around the world. The Hawaiians built this in the 1970s to prove that they could use traditional knowledge to navigate across the Pacific. They didn't build it to prove they could build canoes. It was to prove that they had a relationship to the environment. They understood the environment, and if you use that, you could do a lot with it. And this canoe is going around the world getting people to realise there is a connection back to Earth and our ecosystems. The more you pay attention to that and you can integrate modern technology with that, the more we're going to be able to use things effectively and have an effective society which is going to be sustained over time. Whoops, other way. Thanks to all of those people who've supported what I'm doing. All right, thanks very much.